Okay, so we're looking at the last lesson for today. So we're looking at inverse functions, which is the reverse of the original relation or function, but it does not mean the reciprocal. So remember, the reciprocal is 1 over x, for example. So just keep in mind that the notion for the inverse is x or f with a little -1 at the top. Um, and then, yeah, so that's all it is. So essentially what you're doing is so I'm going to write that down. So your domain becomes your range and your range becomes your domain. Okay. So if we're looking at this example here, f with the -1, so the inverse function of our following points would be 3, 1. So they switch. This one would become 7, 2. So again, your x and your y switch. -7, 3. And then 9, 4. Okay. Same with these guys. These literally just switch. So I'm not going to rewrite the table of values, but this becomes -1 and -1, 0, 0, 1, and 1. So the only thing that changes is this guy. So it becomes 8 and 2 instead. Same if we look here. So I'm going to clear this so we can go down the page. Okay, so we have our domain and our range here. Okay, so our domain would now become these numbers. So all of our x domain. So our x values would be 3, 5, 11, and 21. And our range would be this. So these would be our y values. So it literally just switches the y points or the x points. When it comes to our graph, what happens is we're kind of mirroring. So we have this invisible line here, and it's going to act as a mirror. So what happens is we have this is going to go here on our inverse function, and it's going to go like this. Okay, and then this guy is going to go like that and out like that. So this is going to be our new function. That's going to be the inverse function. This is our original one, and then this is our new inverse function. Okay. And we're going to talk about that a little bit more when it comes to the inverse or that reflecting line. So I'm going to clear this. Okay, so for example, we have our reflecting line here, which is y is equal to x, and it becomes like a mirror. So we have our original function, that's our red, and then the blue is our inverse function. So that's what happens when we switch the points. So your x becomes your y and your y becomes your x. So we're gonna do another example here where this is the original function, and then we have our reflecting line here, which could be drawn a lot better, but it's going to look like this, okay? And that's what is essentially happening. So I'm going to clear this, and we're going to look at a few other things. Okay, so notes about inverse function. So if AB exists in the function, then BA exists in the inverse function. So that's like I'm saying the 2 points switch over. The graph of y equals f inverse is the reflection of y equals x. So like we just saw in the graph, f and f -1 or the inverse function intersect at points along y equals x. So it's going to always intersect or touch each other on that graph. The domain becomes the range becomes the domain. The inverse function is not necessarily a function. So if we were to look back at this guy here, these would become our x points, And if you see here, x or 5 has 2 y's that it's going to lead to. So that means that it's not a function. So it would have started off as a function, but then these guys became our x values, and there's 2 x's here. So that's not a function. So it doesn't mean that the reciprocal or the inverse, sorry, is going to be a function. Okay. So here they want us to graph 5 over 2x minus 2. Okay, so our starting point for this guy is down here. If you remember with grade 9, you do rise over run. So your starting point is here. You go 1, 2, 3, 4, 5, and then over 2. 1, 2, 3, 4, 5, and over 2. And then that's going to make a line, which could be drawn better. So that's our original function. We're going to make our visible line of x is or y is equal to x. So that way this can change. Boop, boop. Okay, so our f, our inverse of this guy is going to look like something along the lines of this. Okay, and you see if it would have been a little bit more accurate, our intersection here is falling onto that reflection line. Okay, I'm going to clear this and I'm going to show you how to find the equation for the inverse function. It is quite easy, I find. So we're going to get to there. Okay. Okay, so our original function that is written at the top was 5 over 2x minus 2. Okay, so you're going to rewrite that. Your first step is to rewrite the function with a y. And then you're going to swap the y and the x. So remember that the inverse means that the x and the y are being changed over. So you're going to do it like this. And then you're going to solve for y. Okay, so you're going to add 2 on both sides. That cancels that out. So we have x plus 2 is equal to 5 over 2y. This is a division, so we're going to multiply by 2 on both sides. So this, we're left with 2x plus 4 if you were to FOIL that. This is being multiplied, so we're going to divide by 5 on both sides. So our inverse function is going to be that 2x plus 4 over 5. So it went from this as our original function, and this is our inverse function. Now they want you to evaluate. So when it has just the f, you're going to replace your x by -2 in that original function. So f of -2 is 5 over 2. Where there's an x, you're going to replace it with a -2. Okay, and that is going to give us -5 minus 2, which is -7. And then when there's that little -1 there, that means that you need to use the inverse function to find your answer. So f of -1 of 20 plus 4 over 5. So 44 over 5 would be our answer. Okay, so we're clearing that. We've just got, no, actually we're done. Okay, so good luck. I hope it goes well. Yeah, and I will talk to you guys tomorrow. So tomorrow's Thursday, if I'm not mistaken. And then we're almost done week 2. So yeah,